Alright, 8.1. Find angle measures in polygons. I think most of you guys already know what a diagonal is. A diagonal of a polygon is a segment that joins two non-consecutive vertices. Remember, consecutive means they're right next to each other. Non-consecutive means the vertices are not right next to each other. Okay, so for example, in this quadrilateral, this would be a diagonal. Okay, in this pentagon, this would be a diagonal. All right, because this vertex and this vertex are non-consecutive. All right, theorem 8.1, polygon interior angles. The sum of the measures of the interior angles of a convex, note that this is only for convex n-gons, is n minus 2 times 180. So if you were to add up all the angles inside any polygon, the sum would be the number of sides minus 2 times 180. And we'll do an example of that in a sec. Alright, a corollary, the sum of the measures of the interior angles of a quadrilateral, remember quadrilateral has 4 sides, is 360. Any quadrilateral, if you add up all 4 angles, you get 360 degrees. Alright, so for example, find the sum of the measures of the interior angles of a convex hexagon. Okay, now remember, a hexagon has 6 sides, so we're going to use the polygon interior angles theorem, n minus 2 times 180. In this case, our n is 6. 6 minus 2 times 180. I plugged in 6 for n because it has 6 sides. 6 minus 2 is 4. 4 times 180. 720. So, the sum of the measures of the interior angles of a hexagon is 720 degrees. Alright, let's go on to page 2. Okay, the sum of the measures of the interior angles of a convex polygon is 1260 degrees. Classify the polygon by the number of sides. Alright, so now we have to work backwards. Use the polygon interior angles theorem to write an equation involving the number of sides n, then solve the equation to find the number of sides. So we know our equation is n minus 2 times 180. But in this case, we don't know what n is. We need to solve for n. But we know that whatever n equals, we're going to end up with 1260 degrees. Okay? I'm going to divide both sides by 180. So if you divide this side by 180, this side by 180, you get n minus 2 equals, let's pull out the calculator. Wrong way. 1260 divided by 180, 7. Okay, now I'm going to add 2 to each side. N equals 9. So the polygon has 9 sides. And if you remember, a 9-sided figure is called a nonagon. Alright? Okay. Example 3. Find the value of x in the diagram shown. The polygon is a quadrilateral. Use the corollary to the polygon interior angles theorem to write an equation involving x. Okay, so if you guys remember, we just learned that a quadrilateral, all the angles are going to add up to 360. Now, if you were to plug in n minus 2 times 180, if n is 4, 2 times 180 is 360, you would get the same thing. This is just kind of a shortcut. If you just remember any quadrilateral, they add up to 360, you're good. So if I add up all 4 of these angles, I'm going to get 360. So x degrees plus 71 degrees plus 135 degrees plus 112 degrees equals 360. Now I just need to solve for x. If I add all 3 of these together, let's see here, 135, 112, 71, and that would be 8, 11, 318. So x plus 318 equals 360. I'm going to subtract 318 from both sides. 360 minus 318. Need to borrow. 42. So x equals 42, in this case 42 degrees. Alright, I'll let you guys do the checkpoint. Let's go on to page 3. I'll let you guys do these 2 checkpoints also. Okay, theorem 8.2. Polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex, note that, it doesn't work for concave polygons. Convex polygon, one angle at each vertex is 360 degrees. This is actually I think, a much easier theorem to use than the other one, because no matter how many sides a polygon has, all the exterior angles are going to add up to 360 degrees. With the interior angles, you're going to get a different sum depending on how many sides the polygon has, but the exterior angles, always 360. Okay, so for example, find the value of x in the diagram shown. These are all exterior angles, so if I add them all together, I'm going to get 360. So x degrees plus 89 degrees plus 2x plus 85, you could put degrees or you don't really have to. All of this will add up to 360. Let's combine like terms. X plus 2x gives me 3x. 89 plus 85, 174. And now I'm going to say, now I'm going to subtract. $186. They actually kind of skipped a step in here. You have 3x equals 186. Divide both sides by 3. 3 goes into 18 6 times. Goes into 6 twice. So x equals 62. Alright, let's go on to the last page. The base of a lamp is in the shape of a regular 15-gon. A 15-gon has 15 sides. Find A, the measure of each interior angle, and B, the measure of each exterior angle. Okay, so 2 things we have to note right at the beginning. First of all, a 15-gon has 15 sides. Secondly, a regular polygon. Hopefully you guys remember. A regular polygon is equilateral and equiangular. It's very important because you're going to see that that word regular a lot in these problems, okay? That means all the sides are equal and all the angles are equal. Okay, so all 15 angles are congruent. Use the polygon interior angle theorem to find the sum of the measures of the interior angles. Okay, so we know our equation, n minus 2 times 180. In this case, n is 15. 15 minus 2 times 180. I'm going to use a calculator for this. 15 minus 2 is 13. 13 times 180. Oop, there we go. 2340. Okay. Then find the measure of one interior angle. A regular 15-gon has 15 congruent interior angles. Divide 2340 by 15. So 2,340 divided by 15. Let's pull out that calculator again. 156. Okay, so there are 15 angles. Each angle is 156 degrees. So the measure of each interior angle in the 15-gon is 156. All right. By the polygon exterior angles theorem, the sum of the measures of the exterior angles, one angle at each vertex, is 360. We don't have to plug it into any equation. It's automatically 360 degrees. So we're going to divide 360 by 15. 360 divided by 15. Let's see here. $24. So the measure of each exterior angle in the 15-gon is 24 degrees. Alright, I'll let you guys do the checkpoint, and that's all.